In this module, we will dive into the iterator pattern. Its intent is to provide a way to access the elements of an aggregate object sequentially, without exposing its underlying representation. I'm Kevin, and I'll guide you through this module. We'll start by describing the pattern, and you will notice very soon that this is a very common pattern, at least to use, not to implement. Yet we are going to implement the custom iterator by automatically iterating over a list in alphabetical order. We'll use that as an example, and after that we will map that example to the pattern structure and implement it in a demo. We will continue with learning about use cases for this pattern and pattern consequences, and we'll end the module, as all modules, by looking into related patterns. Let's dive in. Iterators are everywhere. They're one of the most common patterns used by frameworks to traverse their collection. Yet, even though it's very common, I don't see it used that much in custom code anymore. By which I mean that the frameworks we use tend to already have the iterators in place we commonly need. Its intent is to provide a way to access the elements of an aggregate object sequentially without exposing its underlying representation. Sounds a bit complicated maybe, but simply change aggregate object to enumerable or array or collection, and the intent all of a sudden becomes a lot more tangible. Whenever we use a for each statement over an enumerable, say a list of string, it's an iterator that is used to provide the correct previous or next item. And let's continue with that list example. A list is an aggregate object which aggregates a set of variables, potentially other objects. Lists, but also other aggregate objects like collections, dictionaries, stacks, queues, and so on, keep their items in an internal structure. You don't want to expose this internal structure to avoid it being tampered with in unintended ways. Also, you might not always want to traverse the aggregate object in the same way. You might want to allow traversing it alphabetically or in reverse order. And you don't want to bloat the aggregate object interface with all these different ways of traversing it. And that is what the iterator solves. It takes the responsibility for traversing out of the aggregate list object and puts it in an iterator object. Now, as mentioned, most common iterators on the collections we use already exist. So as an example, we're going to create a custom collection, a collection of people. On it, we're going to create an iterator that iterates over these people, but it's going to do that in alphabetical order by the person's name. We will name our custom collection People Collection. On it, common methods like you'd expect on a collection exist, like add, remove, maybe count, and so on. Next to that, it should also have a create iterator method. That will return our iterator and will define the need for such a method on an interface, iPeopleCollection. So, the iPeopleCollection interface will define an interface for creating an iterator object. We'll name that iPeopleIterator. That too is an interface. Like this, we avoid having to use concrete implementations on our people collection, which means we can easily provide multiple different iterators without having to change the class. The people iterator interface contains 4 methods. First, next, is done, and current item. These are the methods required for iterating over a collection. The last part of the story is the concrete implementation of the iterator, the people iterator. It implements the iPeopleIterator interface, and it will contain the actual logic for iterating over our people collection, sorted alphabetically by name. Let's map this to the pattern structure. We'll start with the aggregate. This defines an interface for creating an iterator object. That maps to our iPeopleCollection. That iterator object, that's what defines an interface for accessing and traversing elements. It maps to our iPeopleIterator interface. And then we have the 2 concrete implementations. The concrete iterator implements the iterator interface, and it keeps track of the current position in the traversal of the aggregate. If we map it to our real-life example, we see that it maps to our people iterator. And lastly, the concrete aggregate implements the iterator creation interface to return an instance of the proper concrete iterator. And that maps to our people collection. Time to implement this in a demo. In this demo, we will implement our custom iterator over the people collection, which will iterate over it in alphabetical order. Let's start with a helper class, a person. Person has a name and a country where the person is coming from. Up next, we define our iterator interface. It's named iPeopleIterator, and it's a copy from the pattern structure mapped to our example. So, what it returns from its methods where applicable are person objects, as that is what we're going to iterate over. The next interface we want to define is our iPeople collection. That's the aggregate. As we learned, it should define one method, createIterator, returning an iPeopleIterator. The concrete aggregate is then our people collection. Now, we could make this hard on ourselves. We could start from scratch with implementing a complete new collection with an internal data structure to hold our set of people, with add and remove methods, indexers, and so on. However, we already have all that functionality in the built-in framework classes. So instead of starting from scratch, we're going to subclass the generic list class. We'll make this derive from list of person. The one thing we do need to add is an implementation for the createIterator method from our iPeople collection interface. So that's something we do have to do. The signature of the method signifies that it returns an iPeopleIterator. The method itself should return a concrete implementation of that iterator. We haven't got that yet, but we know from the slides that we named it PeopleIterator. We also pass through the object itself, as the PeopleIterator will require access to it to iterate over the items. And that brings us to the last part to implement, the concrete iterator, our PeopleIterator. This is where most of the logic resides. Iterators can become quite complex, storing numerous in-between positions and variables to return the correct item. Let's start by implementing the iPeopleIterator interface. In our case, we want to alphabetically order the list. We can again use built-in framework functionality for that. The first thing we will do is create a constructor that accepts our people collection. Like that, the code from our people collection that creates the iterator will resolve again. So, in our constructor, we accept that collection and we store it in a private field. The other field we add is a current field, which will store the current position in our people collection. So the idea is that now we are going to implement isDone current item first and next in a way that returns our people in alphabetical order. Let's start with first. When we want to get the first element in our collection, we can say that we want the current position to be set at 0, and then we return the person at the current position after having ordered the people collection by the person's name. When we want to get the next person in line, we add 1 to the current position. As long as we are not done, that means as long as there are still items in the list, we will implement isDone immediately. As long as that's not the case, we can select the next person in line. We again order the people collection by name, and we get the one at the current position. If we are done, in other words, if there are no more people in the list, we can potentially return null. What you want to do when someone tries to get the next item in a list and there is no next item kinda depends on your use case. Returning null is pretty common here. 2 things left, implementing isDone and current item. These were defined as properties. Getting isDone means checking whether the current position is larger than or equal to the amount of items in the people collection. So that statement will either return true or false. Getting the current item uses the indexer, passing through current test position after having ordered our people collection by name. That should be it. Let's write a little bit of code to test this. First, we new up a people collection. For that, we need to import the iterator namespace. Now let's add a few people to it. These are all fellow authors living in Belgium or the surrounding countries. The next thing to do is create the iterator we'll use to iterate over our collection. For that, we call into create iterator on our people collection. And then we use that iterator to run through all items in the collection. For each person, we write out the name. Like that, we will easily be able to see whether they're truly sorted alphabetically. As you notice, in our for loop, we also use the first, is done, and next operations on our people iterator. Let's give this a try. Let me just add a console.read key statement here. And there we go. And as you notice, the authors are now sorted alphabetically. Let's look into the use cases for this pattern. Use this pattern to access an aggregate object's contents without exposing its internal representation. As mentioned before, this avoids unintended access to and manipulation of that internal representation. Next to that, it can also be used to hide away complexity when you're working with a complicated data structure. Think about complicated tree structures, for example. Another good use case is when you want to support multiple ways of traversal for the same aggregate object. And yet another one is avoiding code duplication. If the way you want to traverse a structure is complicated, chances are it's not trivial to write. If in such a case you want to traverse your structure in multiple places in your app, it's a good idea to put that code in an iterator to avoid code duplication. Let's have a look at the pattern consequences.